Greeting dear users, we are students of Vishwakarma Institute of Technology from first year and we are Division A Batch 3. So let us start with division restoring algorithm. Introduction. We all know what division is. It is a mathematical operation that gives a quotient and a remainder. We will see the hardware implementation of division algorithm in computer architecture. We use registers and counters while performing division. Let's start with seeing the types of division algorithm in computer architecture. Types of division algorithms. The first type. The first one is slow division. In the slow division, we get one digit of the quotient every iteration. The algorithm of slow division category are restoring, non-performing, restoring, non-restoring, and SRT, that is Sweeney, Robertson, and Tosha division algorithm.
So hello everyone, Shreyash Agone, roll number 16 here. I'll be explaining the second type. The second category is the fast division. In this method, the quotient is predicted to the closest approximate to the actual quotient and then the calculation starts. The algorithm for fast division category are Newton-Raphson and Goldschmidt. So now I'll be explaining the restoring algorithm for unsigned integers. The restoring division algorithm is a slow division algorithm that calculates the quotient digit by digit. This algorithm will generate a quotient and a remainder after the division algorithm. Division algorithm in the computer architecture uses registers for storing the numbers and calculations. The division works with the assumption that the dividend is greater than the divisor.
Hello everybody, roll number 14 Aditya Deore here, and today I will be explaining you the flowchart for restoring division algorithm. So on the screen you can now see the picture of Mr. Frank Gilbert, who was the founder of flowchart. The flow process chart was originally introduced by him in 1921 as a structured method for documenting process flow. In his presentation, process charts first steps in finding the best way to do work, and actually it is the best way to understand restoring division algorithms. What's displayed on your screen is the flowchart for restoring division algorithm now. As you can see, the beginning and the end they are displayed over here. Also in between you can see the second rectangle, A is equal to 0, Q is equal to dividend, M is equal to divisor. Here we are putting the values of the dividend and divisor into registers Q and M respectively. The A register is initialized as 0. Then we are doing left shift for AQ, and then we are storing the value of A minus M in the register A. Then we go to the decision making step, which is denoted by a diamond in the flowchart. If the value of the most significant bit of A is 0, then Q of 0 is put as 1, and if it is 1, then Q of 0 is put as 0 and A is restored. So the restoration of A means the initial value of A or the previous value of A is brought back and put into register A. Then N is equal to N minus 1. This is used to decrement the step, and for example your N is 4, then N minus 1 takes it to 3, 2, 1 and 0. And the final decision making step, if N is equal to 0 in the end of the restoring division algorithm, if N is equal to 0, then the process ends. Otherwise it goes back to the second step of shift left AQ.
So hello, this is roll number 17 Bhavesh Agone, and I will be explaining you one example of a restoring division algorithm. So for example, we have taken 11 as a dividend and 3 as a divisor, and let's start with our example. First we need to initialize the values, then we have to perform the left shift operation in which the most significant bit of Q is set as the least significant bit of A. Then we have to perform the operation of A is equals to A minus M, which is similar to A is equals to A plus 2's complement of M, and after performing this operation the A changes to 11110. And then we have to, as you can see in the flowchart, the most significant digit of A is 1, so we need to set Q0 to 0, and Q0, which is the least significant digit of Q, we have to set it to 0, and we have to restore the value of A. So now the value of A is 00001, and we have to decrement the value of N. So we have to perform similar operations further. So we will again perform left shift operation. Then after that we will perform A is equals to A minus M. then A is changed to 11111. Then as the most significant digit of A is 1, so we have to set the value of Q0 as 0 and restore A. So now the value of A is 00010, and we have to decrement the value of 2. So of n to 2. Then after that we have to again perform the left shift operation, and after that A is equals to A minus M, and now the most significant digit of A is 0, so we just need to set the value of Q0 to 1, and no restoration is needed in this case. Then we decrement the value of n from 3 to 2. We again perform the left shift operation, and then after that A is equals to A minus M. Now again the most significant digit of A is 0, so we just need to set the value of Q0 to 1, and here also no restoration is needed. So we'll again decrement the value of n from 1 to 0, and after the value of n reaches 0, when the value of n is equals to 0, we need to stop this algorithm. So the value which is coming in the column of Q is the quotient, that is in this case is 3, and the value which is coming in the column of A is nothing but the remainder, which in this case is 2. So the result is 11 divided by 3 is equal to 3 quotient and 2 remainder. So thank you.
So hello everyone, I am Atharva Adsul. I will be explaining the topic restoring algorithm for signed integers. The restoring division algorithm in computer architecture is almost identical for both signed and unsigned integers. For signed integers, we only take the bits representing the magnitude of both the numbers, and at the end we put the sign with the quotient. Everything else remains the same.
Hello everyone, I am roll number 18 Shiven Agrawal. I will be explaining you the advantages of non-restoring division algorithm over restoring division algorithm. So the very first advantage of non-restoring division over restoring division algorithm is in restoring division algorithm method, the quotient is represented using a non-reductant number system. This is a paper and pencil usual algorithm. Its main characteristic is the full width comparison required to deduce the new quotient digit. Restoring division algorithm is very similar to manual performing long division. Non-restoring division algorithm, that is NDA, comes from the restoring division method. The restoring division calculates the remainder by successively subtracting the shifted denominator from the numerator until the remainder is in the appropriate range. The operation in each step depends on the result of the previous step. Non-restoring division has a quotient digit of set 1 minus 1 instead of the conventional binary digit. The advantage of using non-restoring arithmetic over the standard restoring division is that a test subtraction is not required. The sign bit determines whether an addition or subtraction is used. Thank you. Hope you understood the restoring division algorithm and its subtypes. We were group 3. Hope you like it. Thank you very much.